Hello students, welcome to the physical chemistry lecture. Today we are learning about the particle in 1D box. So in this lecture we are talking about the quantum particles, not the ordinary particles. The quantum particles are the particles which are smaller in size, like microscopic in nature. The microscopic particle follows Newton's classical mechanics laws, but quantum particles or subatomic particles follow Heisenberg uncertainty principle, which is delta x is equal to delta p is greater than or equal to h by 4 pi. That is, this equation means that the simultaneous position and simultaneous movement of the particle cannot be simultaneously measured precisely. That is why this is called quantum particles exist in wave nature and particle nature simultaneously. So today we will learn about the particle in 1D box, which is the simple particle, because here we consider the potential to be 0 inside the box. The particle is considered inside the box is like actually a rock at the bottom of the well, which is at the bottom of the well only, which moves only in one direction, that is x direction. The particle moves in only x direction, or we can consider the y direction or z direction as per your convenience. But just for the information, the particle only can move between the length of the well. The well length is started from the 0 and ended at L. We measure the distance between 0 and L, that is called x. So we take the wave function of the particle with respect to x, that is distance. So we calculate the distance between d and dx and find the probability of the particle between this d to dx area. So we can calculate normalized wave equation for this atomic particle, that is the called as 1. So any normalized wave equation, here the distance is 0 to L. So we can take 0 to L integration psi into psi conjugate into the distance, the volume or area of the particle is dx. So we can take dx is equal to the formula for the normalized wave function is 1. So we can identify that psi and psi star can come as mod of psi in bracket psi square. The limit is same, 0 to L. The particle exists in dx, that is 1. So we can confirmly say that the particle must exist within the well. So that probability of finding that particle is 1. If the probability is 0, then particle cannot exist inside the or outside the system. So here the three types of area are there. Therefore, here in area 1, the potential is infinitely or potential is infinite. And then in second area, potential, we consider potential to be 0. Why we consider potential to be 0? We'll take in the Schrodinger wave equation. Then third area, we consider potential to be infinite. So we can calculate the Schrodinger wave equation and find the energies of the particle or quantum energy, that is quantized energy wave, quantized energy levels, that is n is equal to 1, n is equal to 2, n is equal to 3. We can find energy in this level, energy in this level, and energy in this level. N is equal to infinite. So we can find that particle can exist in multiple energy levels. We have to find just first value. We can calculate the other values. So first we'll find the wave function for the particle in 1D box. Here is particle, outside is infinity, inside is 0, outside also is infinity. Also at the border of the particle boundary of the well, at this point and this point, potential is also infinite. So we take our quantum's best or mother and father of quantum mechanics equation, that is Schrodinger wave equation. We find that H, that is Hamiltonian operator, psi is equal to E psi. Here H is your Hamiltonian operator, that is energy operator. We can operate on the psi wave function of any particle, that is quantum particle. Any quantum particle, we can operate H Hamiltonian operator on that equation, on that wave function, and we can find energy values, that is eigenvalue of the psi wave function. So here we just have to insert the values of the particle in well, that is V is equal to 0, and therefore it only has kinetic energy. The potential energy for that particle is 0. So we expand this equation into the kinetic energy form and potential energy form, and then we find the energy value for that particles. Here x is the distance of that particle from the initial position, so we can calculate the Hamiltonian. The Hamiltonian for that this equation is our best pi h square divided by 8 pi square m del square, that is Laplacian operator in x direction, y direction or z direction, but here only we considering the x direction, therefore y direction and z direction vector is cancelled out, so only we consider x direction. Here del square plus v psi is equal to E psi. So first we separate these two terms with respect to psi, that is h square divided by 8 pi square m into del square psi plus the part potential energy term is equal to total energy term. Here we just consider that the particle exists outside the box, that is V is equal to infinity. V is equal to infinity, or particle at these 2 points, that is boundary of the well. So we can identify the equation. Here we just keep it as it is, and then this V is equal to infinity psi is equal to that. So this is the wave equation. Now we have to find the solution for that wave equation. So here we can calculate each and every possibility of this wave solution. So we just take what is given to us, the psi, here psi and his psi and this psi. The equation can be satisfied with only the value of psi, that is 0. So here psi x is 0, then mod of psi square, that is probability of finding electron in or quantum particle outside of that position or well. Here probability is also 0. So we can definitely say that the probability particle cannot exist outside the well, only exist inside the well due to the potential is 0. If potential is infinite outside the box or at the boundary, particle cannot exist there. Particle only exists between 0 and L value. So we can clear out the infinite potential formula. After that, we will take about the particle inside the well formula. So this is Hamiltonian same, psi is equal to E psi, our best Schrodinger equation. Here h is h square minus 8 pi square m del square plus v psi is equal to E and psi. Here del we can only take about the x direction vector. So we can calculate h square divided by 8 pi square m. Here del is equal to d square psi that and dx square. Here we take the derivative of psi with respect to x, and again we take the derivative of psi with respect to x, that is double derivative. Here v psi is equal to 0, that is particle is inside the box. Then E psi. Here this term cancel out. Let just find the take this part at the outside the box. Then d square psi divided by dx square is equal to 8 pi square. Here we take this inside the, also minus sign is taken in this side. So that is 8 pi square m E divided by h square into psi. Now this term, the total term inside, that is 8 pi square m E and h square, we can take as a constant. We can just call it as a k. So we take this term as a minus of k square into psi is equal to d square psi into dx square. We take this term in left side, so this term gives dx square plus k square psi is equal to 0. Now we got the function for the particle inside the well. So we can solve this equation and find the solution for this equation. Here the trigonometric function of the wave function, that is psi is equal to a into sine of kx plus b into the cos of kx. This solution of the psi can satisfy the Schrodinger wave equation for the particle in the well. So we can take this as a solution for that equation. Here same 0 L. So now we consider particle is at a boundary condition, that is x is equal to 0. Just for our convenience, we have to find the constant a, constant b and constant k inside the equation. Then we can verify the Schrodinger equation and find the value of the energy E0. So we can take that x is equal to 0. Here if x is equal to 0, then psi is equal to 0, as potential at this point is infinite. So we can take that this equation is equal to 0. Okay, so if we take x value, put x values is 0, then a of sine 0 plus b of cos 0 is equal to 0. The sine 0 value gives 0, that is a into 0, plus b into cos 0 gives us value of the 1. So b, this term cancel out, b is equal to 0. We find out that b, constant b values is 0. So this equation reduces and only gives psi is equal to a into sine of kx. This is the ultimate solution for the particle inside the well. This value of psi can satisfy the solution for the particle in 1D box. So this gives, again we can find the value of the x by putting psi is equal to 0. That is a is equal to sine of kx is equal to 0. Here a cannot be 0, that is a is constant, that is for a cannot be equal to 0. Thus this value sine of kx is ultimately 0. Sine of kx is equal to 0. So we can take it from the trigonometry, that is the multiple of pi, that is n into pi. The function of sine when applied on the multiple of pi, it always give the value 0. That is for 0 degree Celsius, for 0 degree sine function gives value 0. For 180 degree, that is pi, this is n into pi, this is 1 into pi, here 0 into pi, that is value 0. For 360, that is 2 pi, we can give the value for 360 degree, we can give the value for pi, that is all values of 0 of the sine gives multiple of n pi. That is why the sine of kx is equal to 0, the sine of n pi is equal to 0, therefore the kx is equal to n pi. Then we can calculate the value of k with respect to n pi divided by x or n pi divided by L. So we found out the value of the k, we found out value of the b, that is 0. Now we have to only find the value of a. So the wave function psi is equal to a into sine of kx. This is the solution for the Schrodinger wave equation for the particle in the 1D box. Now we have to find about the normalized wave function, that is probability of finding that particle inside the box, that is mod of psi square must be equal to 1. So we have to find the constant a. The constant a is called as normalization constant. If you multiply the constant a into the wave function sine of kx, the value must come out as 1. So we have to find the value of the a. For that we have to give the formula for this 1. That is the normalized wave function formula is minus infinity to plus infinity psi into psi star into dx, that is the area inside which particle can be found, that is equal to 1. Here we just have to put this value inside psi, this value inside psi star, dx is dx, and we have to find value of for 1. So we can give the equation normalized wave function is equal to limit 0 to L, because particle is inside the box, that is the length of the box 0 to L, psi into psi conjugate into tx is equal to 1. Here psi into psi conjugate gives mod of psi square, that is 0 to L into dx is equal to 1. Now we have to put this value inside this box, that is a into sine of kx square into dx is equal to 1. Let's take the square of the a and sine kx and put this value, which gives 0 L a square sine square kx dx is equal to 1. Let's take the a is constant, let's take it outside the integration here and solve this equation. So we taken the a square outside the box. Now we have to take sine square kx into dx is equal to the 1. So from trigonometric calculus we can find the value of the sine square of kx, that is sine square of any function. Here we take theta, the value comes out as 1 by 2 in bracket 1 minus cos of 2 theta. So with this, apply this equation to this equation and we get a square outside 0 to L. Sine square is called 1 half 1 minus cos of 2 theta. Here we can take cos of 2 kx into dx and is equal to 1. So we can find this half constant, we can take it outside also with a, which gives a square divided by 2 integration 0 to L. We can multiply this dx with this term and this term, that is dx minus cos of 2kx into dx is equal to 1. We have to integrate this equation with respect to x minus integration of cos 2kx dx, which gives, this is the constant term 2kx, we have to take it under the 1, that is 2kx. Don't worry about this term will cancel out in outside. So cos of 2kx, the cos will change to sine, that is reverse chain rule, is equal to 1. So here we put the value of the k in the box. The value of the k from this equation is equal to 0. We can find that sine 2k is equal to n pi divided by L or x. Let's take it as x, so we terms cancel out. 2n pi into x divided by x is equal to 1. The x term cancel out, then sine of 2 pi, or let this be sine of n pi is always equal to 0. Then this whole term will cancel out and gives only 0. Therefore, the term which will give a square divided by 2x as it is equal to 1. We cancel this integration, is equal to 1. Here we can take s as a value of L. So we can find out about the constant a, that is a square is equal to 2 by L. Then constant gives a is equal to square root of 2 by L. This is the normalization constant for the particle in 1D box. Now we have to just put this value in this side the equation, and the particle wave function for inside the wave can be given. The psi is equal to a, that is root 2 by L, is equal to sine of kx. Now this is the normalized wave function for the particle in 1D box. Now we have just remained is energy values. So we can calculate the energy values from the k. Just 5 minutes ago we found that k is equal to n pi divided by L. Also at the start of the equation we found we considered k square is equal to 8 pi square divided by h square m into e. So we just square this k, gives n square pi square divided by L square, that is q square. Then we equalize these two values to find the value of the energy for that one particle. particle inside the 1D box. So that is n square is equal to pi square divided by L square is equal to 8 pi square m into E divided by h square. Here n is the quantum number, which is quantization of the energy, L is the length of the well, and pi is the 3.14, m is the mass of that particle, which may be electron, proton, neutron, any one of the subatomic particle. E is the energy level or energy, and h is the Planck's constant. We just now have to find the this term is with respect to E. So E is equal to n square pi square h square divided by 8 pi square m L square. So we can cancel out this term pi square, and which gives us n square into h square divided by 8 m and L square. So this is the formula to calculate the energy of the particle in 1D box. In today's lecture, we have learned about the energy for the particle in 1D box, the normalized wave function for the particle in 1D box. So we can definitely say energy levels for this. So students, we have to find the value for the E, that is n square h square divided by 8 into m L square. This term will remain constant as particle only exists at one position. So we just have to put the values for the n. The n is equal quantum number. So we can put 0, 1, 2, 3, dash, dash, dash. If we put the value for 0, the energy will become 0. That cannot happen, as particle must exist, otherwise energy of the particle cannot be 0. So we have to cancel out 0 and we have to put other values for this equation. So let's put n is equal to 1. Here 1 square h square divided by 8 pi L square. So if 1 square is 1, the value comes out as h square divided by 8 pi L square. Now this whole term is called as E0, that is ground state energy. Here n is equal to 1 gives ground state energy. If we put n is equal to 2, that will give 2 square into E0, that is 4 of E0. If we continue this pattern, n is equal to 3, then 3 square into E0 gives us 9 of E0. In this way, we can find out about all the values the particle n exists in this level. When n is equal to 1, n is equal to 2, n is equal to 3, we can find energy of the any energy level of that particle. So this is our particle in 1D box. For particle in 3D box, tomorrow we will record another lecture. Thank you very much.